Now let's do the 32nd problem. Okay, now this is if the function f of x is mx square plus n when x is less than 0, nx plus m when x is greater than or greater than and less than 1. Okay, in between 0 and 1, that is x is greater than or equal to 0 and less than or equal to 1. Now nx cube plus m when x is greater than 1. So if in these conditions, for what integers does the limit of the function exist as x is approaching these both points 0 and 1? That is, he says that the limit exists. Okay, that is, here the LHL and RHL are equal. So for that to be equal, what must be m and n? Okay, he's asking what is the values of m and n. What are those integers where this must, for this to be equal, this function when x is approaching 0 and when x is approaching 1. Okay, let's find out what are the integers. So if you see, well, let's take the number line. Now let this be 0. Okay, let this point be 0. When x is less than 0, this is the function mx square plus n. Okay, and when x is, now when in between 0 and 1. Okay, so let this point be 1 and this be 0. Okay, so when x is greater than or equal to 0, so it be here greater than or equal to 0 and less than or equal to 1. Okay, the function here will be nx plus m. Okay, and for x greater than 1 will be nx cube plus m. Okay, so now let's find out what are the integers, what will be m and n when the limit exists for the function x approaching 0. Okay, so let this be the number line once again. Okay, this is 0. Now x is approaching 0 from both sides. This is 0. Okay, now the function in the left of 0 will be this one, mx square plus n, and for right of 0 will be nx plus m. Okay, so this will be the distance of x, h. This will be distance of this x. So here x will be 0 minus h, and here position of x will be 0 plus h. Okay, now let's find the left hand limit and right hand limit. LHL will be limit f of x as x approaches 0 from the left hand side is equal to limit f of 0 minus h. Okay, h tends to 0. Now let's replace the x in the function with 0 minus h. So it will be limit m in multiplied by 0 minus h whole square plus n. Okay, h tends to 0. So this can be written as limit m, this will become minus h whole square plus n, h tends to 0. Now putting the value of h in the function, we get m 0 square plus n, which will be 0 into m will be 0, so we get n. Okay, so this is the left hand limit. Okay, now let's do the right hand limit. So limit of the function as x is approaching 0 from the right side, that is 0 plus, will be limit f of x is written as 0 plus h. Okay, h tends to and h tends to 0, which is equal to limit. Now let's replace this function x with 0 plus h. Okay, so n 0 plus h plus m, h tends to 0, which is equal to limit n into 0 0 plus nh plus m. Okay, h tends to 0. Putting the value of h in the function, you get which is equal to, now this is 0, then plus n into, not n plus, okay, 0 multiplied h is 0, n into 0 plus m. This becomes 0, so this becomes m. So this is the RHL, left right hand limit. So according to given, it is given that the limit exists. That means the LHL is equal to RHL. So we can say that n is equal to m. This is LHL and this is RHL. Okay, LHL is equal to RHL. Okay, so n is equal to m. So we can write for the limit to exist at this point, both n and m should be equal. Okay, okay, for the limit to exist as x approaches 0, both n and m, both n and m should be equal. Okay, that is n is equal to m. Okay, n should be equal to m. Okay, so that's finished. Now what will be the values of n and m? What will be those integers when the function, when the limit exists when x is approaching 1? Okay, let's draw the number line again. Let this point be 1. Okay, so x is approaching both sides, from both sides to 1. Now here you have greater than 1 is n x cube plus m. Okay, and less than 1 is, or less than or equal to 1 is nx plus m. Okay, so now as x is approaching both from both sides to 1, and let this be h, let this distance be h, so you can write here x is equal to 1 minus h, and here the distance of position of x will be 1 plus h. Okay, so the left hand limit will be limit f of x as x approaches 1, as x approaches 1 from the left hand side is equal to limit f of 1 minus h. Now x is replaced with 1 minus h, and h tends to 0, which is equal to limit, let's replace x with 1 minus h, limit n into 1 minus h plus m, h tends to 0. Okay, so this will be limit n into 1n minus nh plus m, h tends to 0. Now replacing the value, putting the value of h in the function, you will have n minus n into 0 plus m. So this will become n minus, sorry, n, and this becomes 0, and n plus m. Okay, so this is the left hand limit. Now the right hand limit of the function as x approaches 1 from the right hand side is equal to limit f of 1 plus h. Okay, h tends to 0, which is equal to limit, now replacing this x with 1 plus h, so we get n multiplied 1 plus h whole cube plus m as h tends to 0. Okay, now this is 1 plus h cube, so this is as a formula, that is a plus b whole cube, which is equal to a cube plus b cube plus 3a squared b plus 3ab square. Okay, so this is the formula of a plus b whole square. So let's expand this in this form, make it in this form. Okay, so we get limit n multiplied by, now a square, a is this one. Okay, so 1 square is 1, 1 cube is 1 plus b cube, that is h cube plus 3a square, 1 square. Okay, 1 square is 1, b is h plus 3 into 1, that is then h square h square, okay, plus this m, okay, h tends to 0. Now replacing the value of 0 in this function. Okay, let's write one more step. Okay, limit, and let's multiply this inside. N into 1 becomes n, plus n into h cube becomes n h cube, plus n into 3 becomes 3nh, plus n into this becomes 3nh nh square plus m. Okay, h tends to 0. Now putting the value of h in this function, see, this is h, this becomes 0, here we have it, this becomes 0, this also becomes 0. Okay, so we have remaining n plus m, which is equal to n plus m. Okay, so this is the right hand limit. Now here both the right hand limits are, since it is given that limit exists here, both left hand limit and right hand limit should be equal. Now we got it equal. Okay, we got n plus m equal to, here also n plus m, LHL equal to RHL. Now here the limit exists, we can write for any integer value of, for any integers of m and n, limit exists. Okay, see, if example, if this is 10 and n is equal to 10 and m is equal to 20, 10 plus 20 becomes 30. Okay, so left hand limit can be written as 30 and this also can be 30, so 30 equal to 30. See, LHL is equal to RHL, so we can say that for any values, for any integer values of m and n, for any integer values of m and n, limit exist as x approaches 1. Okay, that's it.